In this video, we're going to talk about trees, binary trees, in particular, binary search trees. Okay. So I think that oftentimes students are trying to complete their assignments as quick as they can, just trying to bash it out, trying to copy from some other program we've done and adapt and all that. And I think we kind of sometimes lose what trees are all about. Okay. So I'm going to go through. You see here on the screen, hopefully all this is appearing on the screen. You've got the code on the left, and I've got this freeform whiteboard tool. The drawings will be bad, unfortunately, I'm afraid. But anyway, we'll go from there. We'll figure it out. Okay. So let's talk about what happens when we create a new binary tree. So the way we have it, our binary tree type is the abstract data type that we're going to use to create the B search tree type. Okay. So if you look over here on the constructor, okay, which is on the left-hand side here, all we're getting is that there's a root. Okay, so we know that we have here a node type, element type pointer called root, and that root points to nothing. Okay, so when we run the constructor, all we're going to have is going to be the root. Okay, probably should be a small r if you get the idea. Okay, and right now that root points to nothing. This is a strange tool, but we'll do what we can. Okay, the root points to nothing. That's all we've got. Okay, now remember that the insert function was a pure virtual function in this in the binary tree type. Okay, so I'm gonna have to go to the B search tree type. Okay, and let's go down to the insert and let's just see what's happening so we can understand what we're doing here. Okay. So see if I can get that top of the screen, mostly, but not quite. I think that's just, oh no, okay. So we do. So we have the root we already had, okay? And we're setting up a couple more pointers, okay? We're setting up a pointer to current. Okay, so we get current in here, okay? And we're setting up a pointer, it's making me capitalize, but you get the idea, to the trail current. We'll see why that's important in a minute, okay? And those are our two pointers. Okay, so, oh, we also have, sorry, new node is also a pointer. So we'll get one more new node. Okay, so all of these are pointers to node types. Okay, get these up here. Okay, so all of these, can I cut and paste that? Yes, that helps. So that currently points nowhere. This currently points nowhere. And this currently points nowhere either. Okay. So that's what we have. Okay. We're now creating this new node is equal to new node type element type. So we're sending in some insert item. Okay. So let's say in this case, we're going to send in, let's say, a 10. Okay. So 10 is what we're sending into the function. 10 is an int. Okay. So when we see this line down here, we're going to allocate memory for this new node type. Okay. So I'm going to go ahead and make a circle over here. Okay. And can I write on this? Maybe. Okay. So I'm going to set its value equal to 10. Okay. Can I make that smaller? That's a big old, yeah. So I've created my new node. Okay. Right now, the new node pointer points there. Right. Okay. If not, we didn't give it a name. So that's what it is. It's the new node pointer points to that. We're using pointers instead. Okay. So we have that, okay, and we're setting it's got an L link and R link. They're set to nothing. Okay, they're set to null. We're doing that in these lines here. Okay. Now we can say if this root, okay, which is up here, if this root, okay, does it point to nothing? It does. Okay. So now this root is going to point to our new node. Okay, so we're going to move our new node up to here. And this is going to do just the right part of that. Can I do this thing? Maybe. There we go. that now points there. Okay. We haven't moved current. We haven't done anything else. Okay. So over here, this part's done. Okay. We're going to skip the rest of it entirely, all the way. We're done. This version of insert is over. Okay. So this closes, everything goes away. Okay. So now let's say we're going to do, instead of the 10, we're going to do a 5. Okay. Going to insert 5 now. Okay. Root still points here. None of these other things have any values, including the new node. Okay. So again, I'm starting back at the top here. So the current, trail current, and new node went away, but now they're back. Okay. So now I'm back to here. I'm going to create another new node, and I'm going to copy this and paste it just so it's the same size. Okay. I'm going to create a new node first. I create it first, and then I want to be able to change that. Okay. So I've created my new node in this line. Okay. I'm setting the info equal to the insert item, so that's equal to 5. Okay. And I'm now going to point new node to that. Okay. So now we're checking in if this root is equal to null pointer. Well, it doesn't. Root points to something. Okay. So we don't have, that's not the case. Okay. So now we're going to go down. We're into this next part of the code here. Okay. And we're going to say current is going to point to the same place that the root does. Okay. So I'm going to point current now to the same thing. Okay. I'm on this line right here. Okay. If current item is equal to insert item, so if 10 is current item, if that's equal to 5, then just say we're not doing duplicates. Okay. That's not the case. Okay. If current info, which is 10, is greater than the insert item, and it is, 10 is greater than 5, so we're going to take that link. Okay. We're going to set current equal to current link. Okay. Current currently points there. Okay. Sorry, current left link. Okay. So current left link. If this had something here, it would actually go there, but it doesn't. So now current is back to pointing to null. Okay. It points nowhere. Okay. And we've also set trail current equal, I guess I need to do that before. Okay. Current is equal to this root, right? Well, current's not equal to null pointer, right? Trail current is equal to current. Okay, that's what I didn't do. Trail current is equal to current. Okay, trail current points there. Current did, now current no longer. Current now points to the left link of here. I'm going to put a left link in here, even though there's nothing there. Okay, so it's going to go to the left link of this, which is currently nothing. Okay, so that's where I'm following. Okay. Okay. So I've ended the while for here. So I'm going to go back up here and say while current not equal to null pointer, current does equal to the null pointer now. Okay. So I'm done with that. Okay. I'm out of the while loop. Okay. If the current trail current info is greater than the insert item, okay, the trail current info is here, then the trail current link is equal to new node. Okay, that means this link, I've got that going the wrong direction. I need that to be, that's not going to help me. Let me just do a new line. That's what I want here. Okay. So trail current points to root. I want the trail current left now is going to point to the new node. Okay. And that still points there as well. Okay. So I've inserted that item. Okay. And we're just going to continue on in that way. We're going to use the trail current. Okay. So let's say I want to do another one. So let's do one that's going to be the left and right should be the same. Let's change this to something bigger than 5, but less than 10. So let's say 8. Okay. So we're doing an 8. Okay. So again, following the code, when we start, root is here. It's not empty. So root is there. Current points there, as does trail current. Everything points there. Okay. We're going to create a new node here. The new node is going to have now, instead of, going to have an 8. Okay. So just like before, we're going to see that, again, we're in this loop here. Okay. Current's equal to root, which is where we're at. Current's not equal to the null pointer. Okay. Trail current's equal to current. We're there. Okay. Current item does not equal insert item. So we're good there. Okay. Current info greater than insert item. True. Okay. So current now becomes current L link. Okay. So this now points to there. Okay. And we're in with the while. Come back around. Current does not equal to null pointer. It does not. Okay. Okay. So the trail current now equals to current. Okay. So it points there. Okay. Current does not equal that item. So we're good. Okay. So current info greater than insert item. In this case, no. Current info is 5. The insert item is 8. Okay. So now we're going to set current equal to the right link. Okay. So we're going to copy this little guy. Okay. And he's going to become the right link here. Okay. So current is now going to be pointing this way. Trail current still points there. Okay. And this is a null pointer, points nowhere, because that pointed nowhere. Okay. So I guess I can just leave this one up here, that it points nowhere. This one gets really irritating, doesn't it? Okay. So it points nowhere now. Okay. While loop again, while current not equal to null pointer, current does equal to null pointer. Okay. So we're now down to this again. And if current trail current info is greater than search item, insert item, it's not. So now we're going to let this R link be the new node. Okay. And it points to there. Okay. That still points there. Okay. So that's what we're doing. We're going to keep searching through, going right or left as needed until we get to a null pointer for current. Okay. We then have the trail, and then we know to either put it in the left or the right, depending on the value. Okay. And it allows the duplicates. Okay. So all we ever see is the root. It's all down from there. Okay. Hopefully that helps explain things a little bit more. And again, I encourage you, when you're working with trees, same thing when you're working with linked lists or any of these data structures, draw a picture, get an example that you're working from, draw a picture, reason it out. Okay.